And it's great to see some familiar faces over here, so thanks for joining us. We're gonna talk about some stuff that bothers me in the past, I don't know, 20 years or so. But before we begin, who am I? I'm Shahar. I've been in the industry for just a little bit over 20 years, without revealing any ages, of course. And I just love what I do. I got the chance to work in pretty much every single department and replace every single hat in the R&D. Front-end, back-end, DevOps, DBA, CTO, and without doing anything wrong, I've been also product for a couple of years, but let's keep this one between us. Among other things, I do host a podcast in Israel. I don't know how come, but it became the second most listened to podcast in all of Israel when it comes to tech. And the best part is that I get to sit down with people that are much more talented than I am and much smarter than me, and they reveal their darkest secrets and they tell me about all the stuff that took them years upon years to understand and master and their craft. And I got to listen to it and steal all of their ideas and then share it with you guys. So, without further ado, what we're going to talk about today is something that I personally have some hard time with. I have kind of an obsession, or unhealthy obsession, you might say, about tests that are running way too slow. But before we dive into it, I would like to know you a little bit. With a raise of hand, with a show of hands, who here had to wait 10 minutes to run their tests? Sometimes? Yeah? Okay? Amazing. 20 minutes? Okay, less hands, but still a lot. Over an hour? You guys and I, we're gonna open up a support group. Okay? Yes, I feel you guys. It happened to me before. I will even go even further and say, in my previous company, we had to wait between 6 to 8 hours for the whole CI/CD pipeline to run, and as far as I'm concerned, this is horrible. And just one last question, someone here also does their CI/CD, got in charge of their CI/CD? Yeah? Okay. So I have a bonus for you in the end. So, what happened when we need to wait and wait? For me, running tests and wait forever, it's on the top of the things that I like to do, like watching paint dry, or what goes by, and spinning, and you have no idea when it's going to finish. Now, what's the problem with slow tests? When we have slow tests, and that takes minutes upon minutes, we need to run the test, and then we have to wait. And what we do when we're waiting, we go into someplace else. We're going to check our Slack notifications, our emails, sometimes we go into a coffee break, and by the time that the tests are finished, we are already in a totally different mind space, and that hurt our productivity. But the worst part is, in the CI/CD, it's even get worse. Because what we do in our CI/CD, we deploy our code, and then we have to wait for so long, and the only thing that is left to do is to grind it in every single step of the way, in every single step of our pipeline. Everything will go smooth, and not by the end of, I don't know, like after 28 minutes, a single test will fail, and all our CI/CD will break, and then we have to start all over again. And by the end of the time of the test that is finished, we already went to lunch, and we already met our friends, and sometimes we even already left the company to another one. And it happens. And I would like to validate it. And before we start, I want to share with you what was our setup. It was not so revolutionized back in the day. Our setup was pretty standard. We used Flask at the beginning. We moved from Flask to FastAPI. And then this FastAPI was Dockerized. Because this is what good engineering does, right? We Dockerize everything. That's what we've been taught, so this is how we need to operate. So we had one Docker container that held our application. And we learned about separation of concerns, so we had another Docker running our MySQL. And that was awesome, and it doesn't matter if it's MySQL for this talk or it's any other relational database like Postgres, which is awesome. And what we had a setup that basically worked for a while. And why did it work? Because at the beginning, when we start a new application, this is just a single microservice, and we have plenty of other microservices as well. When we started, we had a couple of tests. We had, I don't know, like a couple of dozens. And you know what? It was good enough. The test ran in a couple of seconds. Life was good. But as times go by, what we have, we've got more tests. And once we have more tests, and at some point, when we start doing something about, we had over 2,000 tests. Today, this specific microservice that I'm going to discuss about, we have over 2,900 tests, which doesn't sound a lot in the grand whole of things, but it takes a long time to run 2,900 tests. So we had to find a different solution. Because we've done everything right? We've done everything that the documentation said, we've done everything that basically is supposed to mock everything, and it's the same in the CI/CD, it's the same in our production, it's the same locally, but it had its downside. So I've done what every developer does when the test starts to be super slow. First of all, I cried. After that, I panicked. And after that, I went to do some research. And in my research, I found out a couple of things. First of all, there are plenty of solutions out there, but none of them fit our needs. So we had to go even deeper. And we tried to think and come up with a solution. So the solution for our problem was, can we think about it in a different way, something more radical? Can we not Dockerize everything, at least not in the test? Can we not use a database, because no database, no problem, right? And can we actually find a way to make these tests run faster? So we figure out that if we're going to change the database from a Docker container when we run the test into SQLite, and yes, we had a winner, SQLite, we can get and we can achieve 97, 90, 98% of everything that MySQL had to offer. So what we did, we decided to try something. We decided only in the test, not to do it exactly as we have in production. We've decided to do it a little bit differently. And we've replaced our production database only in the test with SQLite. And one of the benefits of SQLite, first of all, it's very fast. Second of all, it's very small. And third of all, if you like, and that's what we did at the beginning, you are able to run everything in memory. So basically, it sounds like the perfect solution. But as we know, no solution is the perfect solution ever, unless you know the edge cases. So SQLite is not Postgres, SQLite is not MySQL, and we had its drawback. We had to know those edge cases. And those edge cases were concurrency issues and some foreign key issues, and we had to know what's going on inside of it in order for us to find those edge cases. But those edge cases, once we knew them, all we had to do was to say one thing. We're not going to replace SQLite. We're going to lean into it. And we're going to walk around only those specific parts, and we're going to test them with a real database. So we're still going to get the benefit of real testing, but for the rest of the stuff, we're going to use SQLite in order to do it. And that's where things start to get interesting. Because what we have now is a system that works much faster. But now it's much faster for me to run the test. The next thing that I wanted the developers, when you think about the developer experience, I want it to be better. Because we had so much boilerplate and so much time in order to run every single test and to write every single test, we had to do so much copy pasting and to bring so much mocks and so much other stuff just in order to get started. So what we did, we decided to fix our fixtures. We centralized everything, and then the developers could run very small tests that they had the connection to the database. If they want a user, just say, I want user. If you want like an image for your image processing, just say, I want image. And if you just want any other type of a transaction, you just need to specify, and everything was already ready in the fixtures. What happened was that our development experience became such pleasant that developers enjoy writing tests. So, now that we solved the database problem and we managed to make our developers feel fun in order to run the test, now it's time to boost up our testing speed. And how did we do that? With a show of hands, who heard of XDist? Awesome, awesome. So what XDist does, it allows us to use PyTest. It's a package on top of PyTest that allows us to use as much CPU that we have on the computer in order to run the test in parallel in multiple workers. But unlike any other solution that we found, that was the easiest to implement. Because sometimes when we try to do things when it comes to performance, we feel like we need to be a rocket science in order to do it. And what happened to us, that all it required from us to do in our CI/CD or locally, is just to add one single flag. PyTest -n, which is the number of workers, and auto. That basically means try to make the best of the machine that you are running on. Now, that was just the beginning, because it allows us to open up a whole new world of possibilities. The cool thing, that every single test now run separately, on a separate lane. So each worker could basically get the benefit of running everything it needed, but it required one thing from us. No shared state. Think of it like we think of servers that are serverless, that are stateless. The same thing needed to happen here. No shared state between tests. And that allows us to run as many tests as possible on every single machine, just parallel everything, and make sure that each test runs as cool as possible. But you know how you solve one thing and then you get another problem? That's life, right? So, once we decided to split those tests using XDist, we encountered a different problem. Some of the workers finished early, which was cool. Some of the workers took their time, took their sweet time, and that took forever. So let's say that we have 100 tests, and those tests they were distributed like on 4 workers, so 25 each. Some of those tests were finished in a couple of seconds. The other ones were finished in a couple of minutes. So instead of going on the highway, suddenly we stopped into a halt. And then we went to explore again. And we found that if you add just one more flag, this works still, you can get amazing boost. Because what it does, it basically allows us to say, oh, I'm finished with all of my tests. Let's see if someone else from the other workers got any work for me to take. And that's exactly what we did. Now, the cool part was that once you do it, instead of some of the workers running for a couple of minutes and the other one for a couple of seconds, those that finish as quickly as possible go to give a hand to all of the other workers. So that was, as far as I'm concerned, an amazing boost that all it took from us, two flags, and we've managed to speed up our CI/CD and our local tests by dozens. But you think it's end up here. But you know what happens when you get a taste of speed? You want more, right? You want more. So that's what happened to us. And we realized that it's nice and good that we run everything locally, but by the end of the day, where do we run most of our tests all of the time? Because we want our CI/CD. We want our CI/CD also to be as fast as possible. Because once our CI/CD is fast, we get one benefit that no one talks about. We get confidence. Because what CI/CD gives us, it gives us the confidence to ship and know that nothing is going to break in production. Today, we don't want to ship, pray, and just wait. We just want to ship and know that everything is going to run. Great. So, do you know what's faster than a single machine that runs tests? Do you have any idea? Right, you're right. Couple of machines running tests. So that's what we decided to do. Apparently, there's another PyCon package very maintainable, very awesome. It's called PyTest, PySplit. And what it does, it allows us to divide the testing in our CI/CD on multiple machines. And each one of those machines can still run the XDist from before. So what it allows us to do is to split the test basically like MapReduce just for testing. And that sped up our CI/CD pipeline amazingly. And basically, all it required us to do at the beginning, we ran it a couple of times locally on our machine. Because when we decided to do the distribution of the test, we did not do the distribution by quantity. We've done it by duration. So once we run it locally and we get all the distribution by duration, we know how long the tests are taking. And once we know how long the tests are taking, we were able to divide the machine, let's say 5 minutes here, 5 minutes there, and then we got to split all of the tests with XDist. Now, that was the first thing that we've done in our CI/CD. The second thing, we decided to try and create faster runners. Who uses GitHub Actions? Okay, and you basically have a lot of other runners as well. All of the big companies has them. I've used many before, and what I realized that GitHub Actions, I love them. They're very simple. They're very easy to implement. But once you want more speed, there are other techniques that you can use just for the runners themselves. So what we tried to do at the beginning, when we wanted faster tests, was doing what everyone that has some money do, just toss more money on bigger machines, and hopefully everything will run faster. But bigger machines unnecessarily going to mean that all of our tests are going to run much, much, much faster. And then if I pay twice, but got only like 10, 15% improvement, it's a bad ROI, right? So I decided to do what every engineer that knows what they're doing does. Let's build our own solution first, right? Because that's what we like to do. It's cool. And then I can go to my mom and tell her, Mom, I just built a new solution for ICRCD. So my mom didn't realize what I was doing. All I know is that we spend way too much time trying to build our own solution. We try to configure our own EC2 machines to run the test, and that went horribly wrong and took us way, way, way too much time and cost us way, way, way too much money. So we decided to do double down and to try to run it in our own Kubernetes cluster, which was a big mistake. So if you can avoid those mistakes, I highly recommend it. And after I cried a little bit and after I realized that I'm not a CI/CD engineer and I'm not going to make this runner run much faster, I decided to consult with some of my friends, you remember, from the podcast. So what they told me, why the hell would you do it? Like there are companies that all they do is faster runners. And I checked a couple of them. And what we found out, that just by changing a single line in our YAML file and use their runners, we managed to get 48% faster run machines and 38% cheaper machines. So we managed to speed up all of our process by a lot by changing a single line of code. And you know what? I like it because by the end of the day, let someone else do the heavy lifting for me. So what happened is that our CI/CD became much cheaper, that our CFO liked it, so I got kudos for that. And all of our developers had to wait much less time in order for the CI/CD to run. So let's do a quick recap. We've managed to lower our CI/CD from about 30 minutes, it was 28.5 minutes, but who's counting, to around 3 minutes. This is just a single microservice, thing that we have a couple of dozens of them. So for us, it was a great experience to do it, and the benefits were amazing. So let's recap what we've done so far. We've managed to take SQLite and replace it with our MySQL database only for testing. Remember, only for testing, this is not production. We use XDist in our PyTest in order to parallel them and to have multiple workers running the test at the same time. Then we use fixtures in order to make our test much cleaner and easier to write. We use PySplit in order to separate it only the CI/CD itself into multiple machines. And by the end of the day, we took better runners than what GitHub had to offer just for us to run it. It was much cheaper and it was much faster. Now, I saw some of you taking photos, so there is no need, and I know that I've used all kind of wave of hands over here with the numbers. What I did, I created a whole article for you that you guys can scan it, and over here I've got code examples and the real numbers from what we did, and basically all of the links to all of the libraries that I spoke about, and I tried to make it as fun as possible because I didn't want to squish in too much code example over here because this is 11 o'clock Saturday morning. This is no time for code. It's a lie. Every day and every time it's time for code. So, guys, I would just like to say thank you so much. You guys have been awesome, and I'm here if you have any questions. Yes, CJ.
You mentioned swapping out MySQL for SQLite in memory for the tests. Do you have any suggestions for how to guard ongoing for cases where SQLite has valid, non-failing, or non-crashing code that's different from your production database?
Yeah, so first of all, great question. We had issues at the beginning because we weren't realizing that we did not realize all of the caveats that you have. For example, you have a couple of flags that you would like to explicitly say. For example, foreign keys. Foreign keys, this is something that every major database has by nature. And SQLite doesn't enforce it, so you're going to get nulls instead of it, or auto-increment, or all kind of other stuff like that. So once we've managed to know this, and we know it only after you fail miserably a couple of times, we find out all those caveats. We had a markdown file that we knew what to watch for, and this is like something that we've been working on in order to do it. So this is something that we did. Yeah. I hope it answers the question.
So swapping SQLite gives you quicker confidence in anything not with the integration with MySQL. So presumably you don't go straight from that to production. So what do you have between the CI/CD? So do you have a second set of tests that run lazily at night to give you confidence in your integration with MySQL? Where does that happen before the eventual jump to production?
So that's a great question. Again, what we did was, first of all, to replace the majority of the tests. So we're still going to have we use markers. Markers basically allows us to mark what tests are. For example, some of the tests, we call it E2E. So we run everything that is not E2E related. And in those E2E, we actually do use the MySQL, but in E2E, if we know the pyramid of tests, the E2E is just a small chunk at the top, which is super important chunk. So the first thing that we did, for example, we do use FastAPI and we use SQLModel. And SQLModel basically is an ORM. So it allows us, first of all, not to spend too much time on the queries themselves when we run it. Because for the SQL model, it was transparent, or as far as we concept, it was transparent. We just changed the connection string, and that's all we had to do. So that was the first thing. But when it comes to the tests themselves, so we do have a chunk of tests, and those tests are still like part of the E2E, and we do run them on every single commit. Like not on every single commit, on every single merge. And that gave us enough confidence. The second thing that we did have to do after that, we basically do a comparison. We take our production SQL schema and we run it against what we have now that's going to run in the CI/CD. That's the first test we're going to have because we want to make sure that nothing in our production database differ schema-wise from what we're going to run in tests. So people won't do or introduce any breaking changes without us knowing it in advance. Yeah, cool. Any questions? Yes. Dimitri, you're my man.
How do you make sure you don't have global state between tests? It's quite easy to introduce, for example, by having a cache.
So it happened to us. It was a horrible thing that did happen to us. That we had a singleton for our loggers, and then suddenly we had a test to run the loggers, but they used the same one. So basically, we had to do a workaround in order to make sure that they work totally separately. And at the beginning, we did run all of the MySQL in memory, but eventually what we did instead, that was introduced later on, we basically create a SQLite on the database, on the machine, like in file, and each one of the workers get assigned only that specific one, and the application basically runs differently on every single one. So even if you're going to have the cache, it's going to die the second that the application dies. So we run up the test, and part of the teardown by the end of the PyTest config is just to kill everything that we had before. But it's still very, very fast because everything else runs in memory. But that was a great question that we have encountered and caused 2 errors as well. Any other questions?
Sorry, we are on time.
No time for one more. If we have, I'm not.
Last question.
What advice can you give for defining the prerequisites in SQLite? Because obviously you might have multiple tables required by tests and a very large amount of prerequisites potentially in your database.
Can you repeat the question, please?
Yeah, sure. So obviously you require a base schema in SQLite. What's your advice for establishing that base schema sufficient for your complex tests?
So what we did basically, we used ORM, and that helps us a lot in order to make like the base schema for everything. So we do use this, and then we have a few guardrails, like what can be implemented inside of those schemas, and we try to avoid a lot of like overhead that sometimes I had before in my previous companies that we added to those schemas, all kind of getters and setters and stuff, and some complex stuff. So we try to avoid it, and we use like different functions and utilities in order to do it, and we don't rely on the database for it. We just rely on the execution of the queries itself. Okay, that makes sense. So we'll talk about it later.
Thank you, Shahar.
Thank you, Dimitri. It was my pleasure.